Here we have a pre-calculus problem. Okay, let's go to the question. Determine the limit. That is limit extends to negative infinity, 3x to the third power negative 4x squared positive 9 over square root of 18 times x to the sixth power positive x to the fourth power positive 5. Okay, in this question, x approaches a negative infinity. There is a very large negative value. So whenever x approaches a very large negative value, we have to be very careful with the sign of the result for this evaluation of this limit. Okay, so for that, let me consider the expression we have in numerator. So 3x cubed negative 4x squared positive 9. In this expression, what is the leading term? So leading term is the one which contains a variable with the largest exponent. So 3x cubed is a leading term because it contains a variable x with the largest exponent 3. So when you evaluate the value of this expression, this leading term will dominate the other terms in the expression. So because when I plug in the values of x, always this value will be larger than the values of the other terms in the expression. Okay, so for example, in this one, actually where x approaches negative infinity, that is x approaches a very large negative value. When I plug in a very large negative value for x over here, so what will happen? So here I plug in a very large negative value for x. So because of the odd exponent 3, so the value of this x cube will be again a very large negative value. When this large negative value is multiplied by this positive 3, because there is no sign in front of 3, we have to assume it's positive 3. So when I plug in a very large negative value, that is negative infinity for x, so because of the odd exponent, it will become a very large negative value. When a large negative value is multiplied by positive sign, positive 3, again it will become a very large negative value because positive times negative will become negative. So the sign of the leading term in numerator becomes negative when x approaches negative infinity. So that's a sign of the complete expression in numerator. So when x approaches negative infinity, the value of the expression in numerator becomes negative. Okay, first let me write that over here. Limit extends to negative infinity. So the sign of this expression becomes negative. That is, we can write negative sign in front of the expression. So we can write this expression as it is inside the parenthesis 3x cubed negative 4x squared positive 9. So now let's go to the denominator. In denominator, we have an expression inside the square root, and here the leading term is 18 times x to the sixth power because this is the term which contains a variable with the largest exponent 6. Okay, now when x approaches negative infinity, that is x approaches a very large negative value, so we have to plug in a very large negative value for x. What will happen? So because of the even exponent, even though when we plug in a very large negative value for x, so it will become the value of x to the sixth power will become positive because of the even exponent. So when x approaches negative infinity, that is when I plug in a very large negative value for x, so the value of this x to the sixth power becomes positive, and already this 18 is positive. When we multiply a positive value by a very large positive value, again it will become a very large positive value. So as I said already, the leading term will dominate the values of the rest of the terms in the expression since it becomes positive. So for the entire expression, we can decide the sign positive. So anyways, we have a positive value inside the square root. So it's a real number. In case we have a negative value inside the square root, it will become imaginary. But here, when I plug in a very large negative value for x, because of the even exponent, it becomes positive. When a positive value is multiplied by positive 18, again it becomes a very large positive value. So anyways, that's a sign. Since it becomes positive, so for the entire expression, we can consider positive sign. So inside the square root, we get a positive sign. So it's a real number. Already we have a positive sign outside of the square root because there is no sign. We have to assume there is positive sign. So for denominator, we have positive sign. That is, we can write positive square root of 18 times x to the sixth power, positive x to the fourth power, positive 5. Okay, so always we have to complete this work whenever x approaches negative infinity. If it approaches positive infinity, we don't have to check the work of what I've done so far. Okay, now let's evaluate this limit, that is limit extends to negative infinity. So whenever I evaluate limit at negative infinity or positive infinity, whatever it is, I just have to consider the variable with the largest exponent in numerator. So it's x to the third power. Now I have to factor this x to the third power out from this expression in numerator. Okay, let me factor out. So already we have taken negative sign, negative x to the third power. So when I factor the x to the third power out, what I have left inside the parenthesis over here? To know that, what I need to do is I have to divide each term inside the expression by the one I factor out. Then I'm getting 3x to the third power over x to the third power, negative 4x square over x to the third power, positive 9 over x to the third power. Now, so we can take square root over here. And now the same thing, here in this expression, the variable with the largest exponent is x to the sixth power. It has to be factored out. So if I factor out, so to get the stuff inside the parentheses over here, I have to divide each term by the one I factor out. So 18 times x to the sixth power divided by the one I factor out. That is x to the sixth power, positive x to the fourth power by x to the sixth power, positive 5 by x to the sixth power. Okay, now we have to do simplification. Limit extends to negative infinity, negative x cube. So, okay, this x cube will cancel. I'm getting 3 negative. When I simplify this x square over x cube, I'm getting negative. Sorry, not already I have taken negative 4. We just have 4. And when I simplify this x square or x cube, I'm just getting x in denominator. Because x square or x cube equals to x times x, we can write to x multiplied by x in numerator. And since we have x plus 3, we have to write x thrice. So 2x will cancel. We just get 1 over x. I think everyone can understand this. Okay, now positive 9 over x to the third power over. Okay, now when I move, when I take this x to the sixth power out, it will become x cube. Otherwise, we can do it in the next step. Okay, so this x to the sixth power can be written as x to the third power times x to the third power times. So this x to the sixth power, x to the sixth power will cancel. I'm just getting 18. Positive. When I simplify this one, I'm getting 1 over x to the second power, positive 5 over x to the sixth power. Okay, now let me continue on the next page. Okay, now let's continue. This is the last step of our previous working. Okay, now what we can do is limit extends to negative infinity. I'm writing the stuff in numerator as it is. It is negative x cube times 3 negative 4 over x positive 9 over x cube divided by. Okay, here for every two same quantities multiplied inside the square root, or one quantity can be taken out of the square root. So here x cube and x cube are multiplied inside the square root. For these two x cube, one x cube can be taken out of the square root. Then one x cube will come out. Then inside the square root, we have 18 positive 1 over x square, positive 5 over x to the sixth power. So this x cube and x cube can be cancelled. Then I'm getting limit extends to negative infinity. So negative of 3 negative 4 over x, positive 9 over x to the third power over square root of 18 positive 1 over x square, positive 5 over x to the sixth power. Okay, that's all the simplification we can do. Now in our next step, what we can do is we can plug in the limit negative infinity for each x over here. Okay, let me do it. Negative of 3 negative 4 over. So for this x, we can plug in the limit negative infinity, positive 9 over negative infinity whole to the third power divided by square root of 18 positive 1 over. For this x, we can plug in negative infinity, then negative infinity the whole square, positive 5 over negative infinity whole to the sixth power. Okay, negative 3, sorry, 1 second, negative of 3 negative. Okay, when I divide 4 by a very large negative value, whenever I divide a finite value by a very large negative value or large positive value, that is when I divide a finite value by positive infinity or negative infinity, always it will result 0. So the result of 4 over negative infinity is 0, positive. So here negative infinity is a very large negative value. When I take odd exponent, again it will become a very large negative value. That is, I divide 9 by a very large negative value. So whenever I divide a finite value by a very large positive value or large negative value, that is, I divide 9 by a positive infinity or negative infinity, always it will result 0. Okay, divided by square root of 18 positive, the same reason. So 1 over negative infinity whole square. So actually it's a negative, very large negative value. When I take even exponent, it will become a very large positive value. When I divide 1 by a very large positive value, it will become 0. And the same reason here, very large negative value is raised to the even power. It will become a very large positive value. When we divide a finite value 5 by a very large positive value, it will become 0. So finally we get, so 3 negative 0 positive 0 will just become 3, and we have negative sign over here. So then negative 3 over, in denominator we have square root of 18. Okay, now let's do further simplification over here. That is negative 3 over square root of 18 can be written as 3 times 2. 3 times 3 is 9. 9 times 2 is 18. So I'm getting negative 3 over. So as I said already, for every two same quantities multiplied inside the square root, one quantity will come out. Then I'm getting 3 times square root of 2. So because for these two 3's, 1 3 has come out. This 2 still in the square, inside the square root. So this 3 will cancel out. I'm getting negative 1 over square root of 2. Okay, so here the denominator is an irrational number. Usually when we give final answer to a math problem, so we avoid giving an irrational number in denominator. So to avoid irrational number in denominator, I mean we have to rationalize the denominator. For that I multiply both numerator and denominator by square root of 2. So when I do so, negative 1 times square root of 2 will become negative square root of 2. Square root of 2 times square root of 2 will become just 2. Okay, now I completely evaluated the given limit. The evaluation of the given limit is negative square root of 2 over 2. Okay, now let's go back to the original question. Here we have the actual question. Just now we got evaluation of this limit. It is equal to negative square root of 2 over 2. And we find this result negative square root of 2 over 2 in option E. So the correct answer choice for this question is option E.